Am I audible?
Yes,
Yes,
ma'am.
ma'am.
Yes. So, a very good evening, everyone. Today is day 5, and I'm going to discuss the remaining portion of the t-test. In the previous 4 days, we have discussed about the basics of SPSS. We have seen normality and reliability. I discussed about the non-parametric test, and then we discussed chi-square test. We have seen both type of chi-square test, that is goodness of fit and independence of attributes, right? And after that, we discussed about the t-test. Means yesterday itself, I started with the t-test, and then we have seen the various. The firstly, I tried to explain you the parametric test. Then I tried to explain you the non-parametric. The first test, that is the basic test, the one sample t-test, right? So as per the agenda today, I'm going to discuss the remaining 2 tests of the category of the t-test. That is the first one is the independent samples t-test, and second one is the dependent samples t-test, right? So I'm going to share my screen. Give me a second.
Ma'am, yesterday, while calculating one sample t-test, we put test value 55. Ma'am, how that 55 came?
I think yesterday itself I made it clear when we were discussing the conceptual aspect. We either we need to have the knowledge about the population mean, or we need to hypothesize this using the past experience or past data.
Okay. Okay, ma'am. So that was a hypothesized mean of population.
Yes.
Okay, ma'am.
Any other query? Okay. So I think one more question was raised. I think maybe yesterday or day before yesterday. It was related to the trimmed mean. I don't know who has asked that question. The person is present in the meeting right now.
Yes, ma'am. About 5% remain.
Have you asked, ma'am?
Yes, ma'am.
So I think I have told you this thing. 5% meaning is we are removing 5% outlier from both the sides. So that means we are
Yes,
calculating the mean on the 90%, right? And this is what I have refer also, right?
yes, ma'am.
Okay, fine.
Okay.
So now I'm sharing. I think it is fine, right, Mona ma'am? Anything else?
Ma'am, today I conducted one sample t-test, and when I referred the screenshot which I took yesterday,
Yes.
आपका जो था उसमें like significance was mentioned only for two tail tests, and for my
Hmm.
results I got it for one-sided test and two-sided test also.
So I think it is
Like,
your updated version of SPSS.
okay, okay, ma'am.
Yes. Yes. So I think I have presented my screen. I hope it is visible.
Yes, ma'am.
Yeah. So yesterday we have seen the one sample t-test, and I started from the parametric test. I said this thing that when we are interested to infer something or infer about the population parameters using a sample, we are generally choosing the parametric test, right? In that category, there are numerous tests available. We started from the t-test, and I explained you that t-test generally we are using when the population standard deviation is unknown. In that case, we are using the t-test. And then we have seen the types, that is one sample t-test and two samples t-test. One sample we discussed already yesterday. Today I'm taking two samples t-test, right? So two samples t-test means when you are having the two samples, you are interested to compare the mean of two samples. In that case, you are going for the two samples t-test. In that case, category, or we can say two samples t-test can further be divided into the two parts: independent samples t-test and the dependent samples t-test. So firstly, I'm discussing independent samples t-test. So here you can see the slide which is focusing on the independent samples t-test, which says it is also called the two sample t-test or independent samples t-test or students t-test. So means independent sample t-test is also called two sample t-test or students sample t-test. Then it is an inferential statistical test. Inferential, I think I already said, inferential means we want to infer about the population parameters using a sample. That is why we can call this t-test as an inferential statistical test, right? Which determines whether there is a statistical significant difference between the means of two unrelated groups. So here you can see the font color for the two unrelated groups is different from the remaining words, right? So the meaning is, I want to highlight this thing, I want to say this thing. When we are talking about independent sample status, we need to have two unrelated groups. Means there should be no relationship between those groups. They should be unpaired in nature, right? Or we can say they should be independent to each other. That is why this t-test is known as independent samples t-test. So these independent groups are groups in which the cases in each group are different. Say for example, married and unmarried person. It is quite obvious. Person who are married, they will not be unmarried. Person those who are unmarried, they will not be married, right? So that way, there maybe we can say we are having two groups. One group is married, second group is unmarried. Person who belong to the business class, person who belong to the service class. So that way, you need to understand a particular independent or particular individual will be the part of only the one group. That way, we can call it as a independent samples, right? Now to understand this, I think I have taken this example. Say for example, we are having the gender variable available, and in that case, we can say we are having the two groups, two unrelated groups, that is male and female. So it is quite obvious these two groups are unrelated to each other. That means male cannot be the part of female group, female cannot be the part of male groups, right? So this way, this is the way of understanding independent samples t-test. Now the next slide, which is talking about the nature or the type of variables we need to have to perform independent samples t-test. So the basic requirement to perform independent samples t-test is we need to have one dependent variable, and this variable should be continuous variable, that is numeric variable, right? Then we need to have the independent variable, and this independent variable should be categorical in nature with the two labels, right? So two labels means there should be two groups. Labels means groups, or you can call them as a samples also, right? So whenever we are talking about independent variable, here it should be, or it should be a categorical in nature, and it should have two groups or two samples, right? So this is the basic requirement of the variables to perform independent samples t-test. Now, example, I think first in the first slide we have already seen when we are talking about gender. So gender can be independent variable where we can have male and female, or occupation where we can have the business class people and the service class people. So that way, these are the two examples of independent variable with two labels or two groups or two samples. I hope this is clear to everyone. Any
Yes,
doubt?
ma'am.
Yes, ma'am.
Okay, fine. Thank you. Further, I think yesterday also I had word regarding this particular thing, sample size, right? So usually this is a notion, this is a general myth or tendency about of the people. We are generally studying in research or maybe in research methodology or statistics. We have studied theoretically this thing that when the sample size is 30 or below 30, we are performing t-test. But when it is above 30, we are going for the z-test, right? But I think yesterday I said one thing. There is a theorem called central limit theorem, which is generally emphasizing as we are increasing the sample size, our data is tending towards to the normality, because normal distribution is the one important assumption of the t-test. Second thing, when we are talking about t-test, generally the population standard deviation is unknown, right? So we can call that when population standard deviation is unknown, rather than performing Z, we should perform t-test, because the basic requirement to perform z-test is that you should have the idea about the standard deviation of the population. So that is why I think, as I said, many a time it happens we are using or we are working with the data, we are working with the sample, and we are not working with the entire population. So reason is maybe we are not knowing, or we are knowing but it is not possible for us to access each and every member of the population. That way we cannot calculate the mean, or we cannot calculate the standard deviation, right? So generally we need to apply t test over z test. So the central limit theorem says when we are having the sample size greater than 30, generally t distribution is becoming or going towards to the normal distribution, right? So this is about the sample size. I think it is clear. May I proceed?
Ma'am, please go to last slide. As in the first line, it is a return that t-test is necessary for small samples because their distributions are not normal. And yesterday we studied that for applying t-test, the data should be approximately normally distributed. Means what we were interpreting yesterday that data should be normally distributed. And the
You
first line is it controversial?
I think, ma'am, you can see this thing. It is written if the sample is large, greater than equals to 30, then the statistical theory says that the sample is normally distributed. And there is a limitation of, means I can say this thing. This is the assumption of the t-test that we need to have the normally distributed data, right? And you can see, as I said, from I think last 2 days, I'm saying this thing that when the sample size is 30 or more than 30, our data is showing us the normal distribution. Usually, this is the theory says, right? So that is why I am again repeating this thing. You do not need to see this n value. You need to see whether you are knowing the standard deviation of the population or not,
Okay, ma'am.
right? Now, moving to
Yes.
the next. Yeah, thank you, ma'am. So moving to the next slide, talking about the independent sample status. So hypothesis, you can see yesterday also I have shown you the one-tailed test hypothesis and two-tailed test hypothesis. So here also we are discussing the one-tailed and two-tailed test hypothesis. So the first serial number, which is for the two-tailed test. Here you can see, as we are talking about the independent sample test, that means we want to compare the mean of the two populations, right, using the two samples. So generally our hypothesis says mu1 is equals to mu2, where mu1 is the population mean of the first population, mu2 is the population mean of the second population, right? So we are saying in the null hypothesis that mu1 is equals to mu2. Alternatively, we are saying mu1 is not equals to mu2. Means it can be possible that mu1 can be either greater than or it can be either less than, but we are only indicating mu1 is not equals to mu2. That means this is the two-tailed test where both the possibilities are existing, right? So in that case, again, you can see this graph says that your rejection reason will fall on both the tails because we are dealing with the two-tailed test, right? And the remaining reason, the middle reason will become your non-rejection reason of your null hypothesis. Secondly, when I'm clearly writing mu1 is greater than and equals to mu2, that is population mean of the first population is greater than or equals to population mean of the second population. This is your null hypothesis. Alternatively, you are saying mu1 is less than mu2. So when I'm clearly declaring this thing that first population mean is less than second population mean, this way it is known as the one-tailed test, right? So in that case, your rejection reason will fall on the one of the tail of your this particular normal distribution curve, and remaining will become your rejection reason of your null hypothesis. Sorry, acceptance reason of your null hypothesis. Next says mu1 is less than and equals to mu2. That means first population mean is less than or equal to second population mean. Alternatively, we are saying that first population mean is greater than second population mean. So again, you can see we are clearly indicating this thing. So that way it is a one-tailed test, and that way you can find rejection reason is again falling on the first on the one of the tail, and that way the remaining reason will become your acceptance reason of your null hypothesis. So this way we can formulate the null hypothesis and alternative hypothesis of the t-test symbolically, right, for the one-tailed and two-tailed test. Now if I talk about in the word form, in the text form, if I want to write my hypothesis, I can say there is no significant difference in the group 1 mean and group 2 mean, right? Alternatively, I can say there is a significant difference in the group 1 mean and group 2 mean. Or this is the case of two-tailed test. In all section, you can see group 1 mean is significantly less than or equal to group 2 mean. So that way it is the one-tailed test. Then group 1 mean is significantly more than or equal to group 2 mean. So it is again a case of one-tailed test. So that way you can write your null hypothesis in case of one-tailed and two-tailed test in terms of text or in terms of words, right? Now, I think yesterday, Rao sir, or I think, I don't know, one of the participants says this thing also. We can, if we are writing mu1 is equals to mu2, so I can transfer this mu2 at the left hand side like this. So I can write mu1 minus mu2 is equals to 0. That means in both the population mean there is no difference, which we are stating in terms of word also, right? So that way, this is another way of writing your null and alternative hypothesis. Now, talking about the manual procedure, as yesterday I have shown you also for the one sample t-test. Now we are discussing for the independent sample t-test. Whenever we are talking about the steps or procedure of performing any statistical test, so the first step always says you need to write your null hypothesis and alternative hypothesis. So you need to clearly jot down what is your null and what is your alternative hypothesis, and it is possible only when you are able to find your dependent and independent variable clearly, right? After that, you need to write the alpha value, that is the level of significance. That means how much percent alpha is, but nothing but it is a level of significance, which means the probability of type 1 error, right? So that way you can write it is 5%, 10%, 1%, whatever percent you want to take. Further, you can write the degrees of freedom. Degrees of freedom is DOF or DF, which is N1 minus 1 plus N2 minus 1. First means total number of observations in the first sample minus 1. Total number of observations in the second sample minus 1. Then acceptance, then we need to state the decision rule. So as yesterday before yesterday, in both the days, I think I had word with you people and we have discussed this thing. In manual processes, how you can write the thumb rule. So this thumb rule says when your calculated value is less than tabulated value, you are going to accept your null hypothesis, right? So that way, this way you can write that if calculated value is less than tabulated value, we are going to accept null hypothesis at 5% level of significance and for X number of degrees of freedom. This would be your set. This will be your decision rule. Then further, you can calculate the t value. So using this particular formula, manually we can calculate the value of t, where you can see formula says x1 bar minus x2 bar divided by sp square in brackets 1 by n1 plus 1 by n2 and the whole square of this. So this way you can see, you can calculate the value of t, and sp is nothing but it is the pooled standard deviation, and the formula you can see in the next section, in this particular section, lower section. And that way, one more thing is there. Generally, there is one more assumption of the t-test which we are going to see in upcoming slides, which says the equality of variance in the groups, right? So if equal variance is there, the previous one, a formula which I have shown you, that you are going to use it. But if your variance is not similar, in that case, this formula of the t-test will be used, and for degrees of freedom also we need to use this formula. So you can see this degrees of freedom value different in the output also of the SPSS. After that, you need to state your conclusion. After that, you need to state your results and conclusion. Further, again, I am showing you the table of the t-test, where you can see degrees of freedoms are listed at the extreme left column. And then you can find these are the one-tailed and two-tailed probabilities, that is the level of significance figures. So you can select any degrees of freedom according to your data, and that way you can, according to your level of significance in the intersection part, you can find the value of t. So here I can show you this. I think I have taken this, yes. So suppose you can see, suppose you are having a total number of observations, 13 observations you are having. So 13 observation meaning is that your degrees of freedom will be n minus 1, that is 13 minus 1, that is 12. So that way you can locate 12 is coming here. And suppose you want to test your null hypothesis at 5% level of significance, which is 0.05. And suppose you have made your null hypothesis for the two-tailed test. So suppose you are locating the 5% against this two tail test, which is this. So the intersection point of these two will give you the value of the t-test, which is 2.179. And suppose your calculated value is 1.78, you can compare these two figures. So it is quite clear that calculated value, which is 1.78, is less than 2.179, right? So that way you are going to accept your null hypothesis. So this is the manual procedure of calculating the t-test. I think till this point it is fine.
Yes, madam.
Yes, ma'am.
Okay, fine. Thank you. Moving ahead, talking about the very important portion of the t-test, which is the assumptions of independent samples t-test. So the first assumption says that independent variable should be categorical. That means it should be measured on nominal or ordinal scale, right? So you need to check. I think this is no software can check this thing. Being a researcher, being a statistician, being an academician, you need to check this by your own. Which type of variable you are having? If you are having a variable on categorical scale, you can treat that variable as a independent variable, right? Second assumption says the dependent variable should be continuous. So whichever value you are having as a numeric or continuous in nature, that variable you can take as a dependent variable. So these are the two basic requirements. I think I already discussed previously also. And in the assumption section also we can see them. Next says there is independence of observations. That means you can collect data from one person only once. If you're not doing this, if you're collecting data from one person more than one times, in that case this assumption will be violated. So these three assumptions we can check by our own. There is no need we do not need to take any help of the software for this, right? Further, the dependent variable should be normally distributed in both the groups. So as I already told you, in case of the t-test, we need to have one dependent and one independent variable. And in independent variable, there should be two groups or there should be two labels or samples. So in both the groups or in both the samples, your dependent variable should be normally distributed. Further, talking about the dependent variable has no significant outlier in the group, in either of the group. So again, for checking the outliers in the dependent variable, you need to check outliers for your continuous variable in both the groups, right? And lastly, the variances of the dependent variable in both the groups should be equal. So this way, these are the 6 assumptions, out of which 3 we need to ascertain by our own without taking any help of any software. And last 3 we will check using the software. Is it okay?
Yes, ma'am.
Yes. Now, if generally statistics says this thing, if assumptions are not followed by your data, in that case, you can go for the non-parametric test. And in case of independent samples t-test, we have substitute test available in the non-parametric test category, and the name is Mann-Whitney U test. Fine. Is it okay? May I proceed?
Yes, madam.
Okay, ma'am.
Yeah. Now, I think yesterday also I have shown you the same histogram as I was discussing yesterday about the normality. As you have seen, one of the assumptions of the independent sample status is the normality. So this is also we have discussed that I think it is very hard to get exact normal distributed data. So that way, if your data is showing such type of histogram, or maybe little deviation can also be possible according to your data, you need to ascertain, you need to decide whether you are treating that data as a normal distributed data or not. So for an example, I am showing you, as you can see, this particular histogram is not exactly normally distributed, right? But still, we can say somehow we can treat it as a approximately normally distributed variable. Now, talking about the last assumption of the independent sample t-test. That is about the equal variance, right? So whenever we are talking about the equal variance, we need to have one hypothesis available. And you can see for checking the equal variance, we are using the Levens test. And the null hypothesis for the Levens test says sigma 1 square minus sigma 2 square equals to 0, or sigma 1 square is equal to sigma 2 square. That is the variances of the two populations of two groups are equal, right? So this is the null hypothesis, or the uh, uh, means assumption of the equality of variance, right? And alternatively, you can say sigma 1 square is not equal to sigma 2 square. That is, population variances of two groups are not equal. So I hope you have noted it down. This is very important to note down. So you need to note down, because once we will go to the SPSS, I'll ask you what was the hypothesis and then what is the decision we are making. Then talking about how to perform the t-test using the SPSS, I think these are the steps, but I think rather than noting them, you need to practice it so that you can be able to recall easily whenever you are using SPSS, you can perform. So this is about the basic and conceptual aspect of the SPSS. Any other question on this? Any thing, or else I can move for the what I can say file. I think I already shared a file with the name employee data with all of you, right? Is it available?
Yes, ma'am.
Okay, so may I know how many of you are performing? Mona ma'am performing. Good. Then
Why?
Chitra ma'am, you are also performing?
Yes, ma'am.
Okay, great. I think today there is less number of people have joined, maybe because of weekend. Indranil sir, are you performing today? I think sir is busy. Okay, no problem. So if you are performing, I'm expecting you to open the same sheet. If you have opened it, please give me a nod. Say yes to me so that I can proceed.
Yes, ma'am.
Done? Okay, fine. So friends, here you can see we are having so many variables available listed in this particular data file, right, of the SPSS. I'm expecting you, if suppose I'm taking the salary variable and I want to take the second variable as gender. So suppose these two variables we are having. So now using these two variables, if I want to see the difference in salary as per the gender, can any one of you tell me what will be the way of formulating the null hypothesis in case of these two variables if I want to find the difference in salary? Anyone will try? Yes.
Ma'am, there is no significant difference between the mean salary of male and mean salary of females.
Very good. It's Mona ma'am, right?
Yes, ma'am.
Very correct. So we can say this thing, there is no significant difference in the mean salary of male and female, or there is no significant difference in the mean salary of male employees and female employees, right? This would be the easier way of making the null hypothesis. So when I am writing this hypothesis, I'm coming to this. Yes. So as ma'am said, I am writing here, there is no significant difference in the mean salary of male and female employees, right? So this way I have written a hypothesis. So here, can any one of you tell me which will be my dependent variable, which will be my independent variable? Anyone? Any attempt?
Ma'am, independent is gender and dependent is salary.
Dependent salary and independent male and female.
Very correct. I can write the dependent variable is salary, independent variable is gender with two labels or two groups, which is male and female, right? So this is the basic
Yes.
requirement which we have seen, and I can say this dependent variable is nothing but this is sorry, continuous in nature. Similarly, gender is categorical in nature, right? Is it clear? So the first two assumptions we have checked, or we have ascertained, I must say. Third assumption was that we need to see that the observation should be independent. That means I can assume here we can take assumption that from one male we are collecting data only once, and from one female we are collecting data only once. So that way this assumption is also, we can say, met by the data. So three assumptions I think we have seen here. Is it okay?
Yes,
May I
ma'am.
Yeah. Now for the further assumptions, you need to go to the analyze menu. Then you can go to the descriptive statistics, and then you can select the explore. Fine. Everyone has located
Yes,
this?
ma'am.
Yes. Once you are clicking on this, you can see we are on the explore dialog box. You need to shift your salary, that is current salary variable, in the dependent list box. I think we have seen this thing. I think in my word file I have written only salary is our continuous variable, which is we are taking as a dependent variable, right? Then gender we are shifting in the factor list box. That is the independent variable list, right? Is it okay?
Hello.
Yes, ma'am.
Yes.
Yes, ma'am.
Sorry. Any question anyone is asking? So may I proceed?
Yes, ma'am.
Yes. So now we need to click on the plots button. Here I'm deselecting this family and selecting the histogram, and then selecting this normality plots with tests. It is fine. May I click on continue?
Ji, ma'am.
Yes. So I think now we need to only generate the output. So I'm clicking on the OK button. Yes, we have got the output. We can see here, case processing summary is the first table which says in the current salary, if I talk about current salary, which is our dependent variable, and in the gender, we can find we are having two groups, female and male. So there are total 216 females and 258 males, right? No missing value in any of the groups. So that way, total is this. Coming to the descriptive statistics, you can find that if I am shifting something in the factor list box, that is what we have done, right? By shifting the gender, you will always get your descriptive statistics in the two section or whatever number of labels available in your factor variable. Accordingly, you will get these sections. So you can find for current salary, here you can see all the statistics is related to the female, and in the next section you can find it for the males, right? So we can say for the female, mean salary is 26,031.92, right? Similarly, for the male, it is 41,441.78. 95% mean, 95% confidence interval for mean. So I think this is already we have seen that if we are picking any of the sample from the same population, so chances of following the mean of that sample will be in this range, right? For the female and for the males also. 5% mean, 5% we are removing from both the sides of the data, and then we are calculating the mean. So this way, this is 26,248 and 39,445. So you can see in case of male, it is the difference is less, right? No, sorry, difference is more. 41,000 and 39,000, approximate $2,000 difference we can find. Here also the difference is approximate similar. Approximate 1,000 something is the difference. Median salary for female is 24,300. It is the 32,850. Variance, standard deviation, minimum, maximum value, range. These are all listed for the female, similarly for the male. Main thing is the skewness and the kurtosis. So you can see skewness is positive as plus sign is coming. Kurtosis is also positive. When skewness is positive, we can call it as a positively skewed data. And when kurtosis is positive, we can call it as a leptokurtic data, right? So here you can see yesterday, or I think the day when I was discussing the normality and reliability, that is day 2. I said there are certain threshold ranges for skewness and kurtosis, and it is -2 to +2 for skewness. So somewhere you can find that this particular figure of skewness is coming in that range, but kurtosis is or kurtosis value is exceeding that particular range, right? So that means there is some dubious condition or doubtful condition in case of the current salary for the females. I cannot ascertain clearly that whether the salary is normally distributed or not. That we will confirm further. Going to down. For male, you can find skewness and kurtosis. Again, you can see, but here you can see skewness is in the range -2 to +2, and kurtosis is also in the range, right? But going down, looking at the test of normality. So looking at the test of normality, we can see, if I talk about the Shapirow-Wills test, you can see its significant value is 0.000 and 0.000 in both the cases for male and female. So can anyone tell me what conclusion we will draw from this test of normality table?
That the data is following non-normal distribution.
Right. That means your data is not normally distributed. That means your current salary for the male and female, for both the groups, it is not normally distributed, right? So,
I have a question. What if for the female, the p-value is less than 0.05, and for the male, the p-value is more than 0.05?
So in that case, salary will be normally distributed for male and not normally distributed for female.
Okay, and okay, thank you.
Yes, ma'am. Now going to down and looking at the histogram, you can see histogram for the female. As you can see, it is written female. For female, you can find this histogram is showing that your data is positively skewed. And I think I have shown you how to put a bell-shaped curve. You need to double click on this. You will be on the chart editor. In the lower bar, you can find we are having this normal distribution curve. From the right side, you can find the second option, show distribution curve. You can click on this. So one more box is opening. You need to only close it. You need to close your chart editor as well. And once you're closing it, you would be able to see that this particular bell-shaped curve is showing that your right tail is greater than your left tail, right? So that way your data is positively skewed data. Coming to the gender, that is male category. Again, you can find it is very much clear that our data is not normally distributed. It's clearly positively skewed data, right? Once again, you can put the bell-shaped curve on this also, and that way you can ascertain this thing also, right? QQ plot, you can see there is more deviation in the particular data point from the fitted line for the female data, right? Similarly, for the male data also, you can find there is deviation, right? Deviation is very high. So that way, again, QQ plot is also showing that data is not normally distributed. Now going down, talking about the box plot for male and female. So I think this way you can see box plot is also saying that outliers are present in the data. Circles are okay, these are insignificant outliers, but asterisks are the highest value, that is the significant outlier. That means they will impact your results. So that would be your call. You can click on these. I think I have shown you. You can select any of the circle. You can select any of the asterisk sign. Sorry, you need to double click on this. I forgot. And then after double clicking on this, you can select any of the circle, and then you can do the right click and click on the go to case. That way you can see all the outliers will be highlighted. So that way that would be your call whether you want to delete them from your data, right? So this way you can ascertain all the assumptions. I think we have seen normality, we have seen outliers, we have seen the homogeneity of variance, that is equal variance. All the three assumptions we have seen for the particular data, and we have seen all the three main assumptions are violated by the data, right? So generally we need to go for the Mann-Whitney U test, but some of the literature says generally for normality, your t-test is the robust test, but I think you need to find in literature it is available. So if you are finding it and still you want to perform t-test, generally it says we should go for the parametric test first, right? So in that case, our researcher can take a call whether the person need to perform this or not, right? But for the demo purpose, I'm showing you how you can perform the independent sample t-test using the SPSS. For that, you need to go to the analyze menu. Then you can go to the compare means, and then you can select the independent sample t-test. Is it fine?
Excuse me, ma'am.
Yes.
Ma'am, have you closed that normality distribution analysis?
Close it.
Yes, ma'am. Like that outlier 29.
No, I haven't deleted
Ma'am,
any.
how to go to that case?
Double click on this. Start editor will open. You can click on any of the circle or asterisk. Then you can do the right click and then go to case.
Okay, ma'am. It will directly relocate to that particular case. Okay, ma'am.
Now we are talking about how to perform t-test. Go to the analyze, compare means, and independent samples t-test. It is fine.
Yes, ma'am.
Click on this. A box is coming. You can shift your required variable, that is current salary, into the test variables box, and gender into the grouping variables box, right? Now once you're shifting your variable into this dialog box, you can find that the define groups button is activated. You can click on this to fill these question marks. You need to click on this. Then you can write, I think it is given as F and M. According to data, I think we have seen this data previously also. So group one.
Ma'am, is there anything like a dependent and independent variable here?
Sorry?
Ma'am, is there anything now dependent and independent variable here?
May I know who is speaking?
Ma'am, I'm Konak.
Konak. I think, sir, we discussed this thing. Have you joined just?
Yes, ma'am. Yes, ma'am. Actually, here, ma'am, raining in Tripura. Network issue, ma'am. Little.
So, sir, I think in the conceptual part, I explained this thing. That generally this is the bifurcation of the SPSS. It takes the continuous variable as the dependent and categorical variable as the independent. So salary we know the continuous or numeric variable. So we are shifting that into the test variable.
Okay, okay. Thank you, ma'am. Thank you.
Yes. So I think I was, yes. So I think now I can check also. We can go to the variable view. Yes, you can see in the gender value labels, and then you can find female, F is female, M is male. So F and M values we have given. I'm closing this. Again, going to the analyze menu. Now selecting the compare means and then independent sample t-test. Now shift on the, select the salary, shift in the test variables box, gender into the grouping variable box, clicking on the define groups here. You can write F as your first group and M as your second group, and you can press on continue. I think this is all you need to do. Except this, you do not need to do anything. You can directly click on the OK. Once you click on the OK,
Ma'am, one thing I'd like to know, ma'am, what is string in the variable view? Just have show Just sin, ma'am. That is string. Yeah, this type is string. Gender.
I
Gender
think
is
the
string.
day 1 class you have joined, right? I think I explained you these are the variable type.
Okay, ma'am.
So you can see in the data view, your data is listed in the form of MF, MF, MF. M and F is what? These are the string, these are the characters, right? If I
Yes,
have
ma'am.
written here 1, 2, 3, so and still I have set here as a string, so 1, 2, 3 will also be string. But if I want to change the variable type, I can come and change it as a numeric in case of when I'm having the numbers. But here we are having these alphabets. These are nothing but these are character or these strings.
Yeah, thank you, ma'am. Thank you.
Okay. So I think we were on the output window, right? Yeah. Till here, I think you people have got the output. May I start explaining the interpretation part?
Yes.
Yes. So you can see in the group with statistics, if I say this particular table says female 216, male 258, mean salaries of both the groups are listed in the next column, and then standard deviation and standard error of mean are listed. This is the group statistics, right? Going down, talking about the main table, that is the t-test table, which says, you can see in the first section, which is in the white, you can see background is white. I'm talking about this particular section. So here you can read the name Leven's test for equality of variances. We need to check the one more assumption of the t-test, equality of variances. So I think I forgot to tell you at that time, this assumption we can check only in the output of the t-test, right? So here you can see the significant value of this is 0.000, which is less than 0.05. That means we are not going to accept the null hypothesis. And can anyone tell me what was the null hypothesis for the Leven's test? Yes.
Should I?
Yes. Anyone?
Ma'am, variance of male group is significantly I'm saying alternative hypothesis. Variance of male group is significantly different from variance of female group.
Very good. Means we can say that the salary is in the variance in the salary for male and female is not same, right?
Yes, ma'am.
So here you can see we are not accepting the null hypothesis and we are concluding this thing that variance is not equal for the salary in both the groups, right? So that way the first line says equal variance is assumed, but I think our data is saying to assume unequal variance. So we are going for the next row which says equal variance not assumed. So in that row now we need to go. So now there is nothing to do with the first row. This row is not useful for us now. So we will now report the results of the second row. So which says the t value is minus 11.688. For the degrees of freedom, 344.262. If any one of you can recall the slide which I have shown you when we were discussing the manual aspect of the t-test, in that case, I have shown you one big formula for the degrees of freedom, right? So in the first case, formula was very simple, n1 minus 1, n2 minus 1. So that is why we are getting a whole number here. But in the second case, when variance is not equal, we will get the degrees of freedom like this particular way. So many time possibility is that your degrees of freedom will be in the fraction form, in the decimal point, right? So now the significant value for the t-test is 0.000 here, which is less than 0.05. So that means we are not going to accept the null hypothesis of the t-test. So can any one of you tell me what will be the conclusion here if I'm not accepting the t-test hypothesis, null hypothesis?
There is a significant difference between the mean salary of male and mean salary of females.
Very correct. So that means we are concluding there is a significant difference existing between the mean salaries of male and female employees, right? So now if I'm saying significant difference is existing, so whether this difference is more than or greater than, if it is more than for male and female, we need to check that. So you can see the mean difference is coming as minus $15,499, right? So that means this is negative and we have taken first group as female, right? So that means the mean salary of the males are more, or you can ascertain this thing using this particular table. So the mean salary of females are less in comparison to the males. So you can conclude this thing also that males are drawing more mean salary in comparison to female employees, right?
Yes, ma'am.
Okay, so any doubt in the independent sample t-test? Any question? Or shall I go for the dependent sample t-test now? Yes,
Ma'am, how this like analysis can be imported to the Word document?
there is an option, ma'am, telling you. First thing is either you can copy it, right? First thing is this, means you can come here, you can do this right click, and then you can copy this. This is the one thing, right?
Okay.
Second is copy as. So now if you want to bring this output in the Excel sheet or in the plain text, in the image form or in whatever form. So these are the 4 ways available. Third one is you can see the export option is available, right? You can click on this, and once you will click on this dialog box will appear. Here you can see first section is asking you objects to export. So by default it is taking selected, means whatever is the selected item available in your output viewer, you want to extract that only, or you want to export that only, or else you can click on all visible, or you can click on all whatever is available in the output viewer, up to you. Then in the second section it is asking you in which type of document you want to export your data. So by default it is Word file. You can select any of the other options available here. And then in the file name, you need to give the location where you want to extract or export your output. So you can, this is the by default location. If you want to change, you can click on the browse, and then you can decide upon in which particular section you want, or at which particular location you want to get your output, right? So that would be your call, and then you can click on the OK button. Fine.
Okay, ma'am. Ma'am, can we write interpretation also of this analysis using SPSS?
Man, how it is possible? No software is giving the interpretation to us. This is then what will be the work of researcher?
Yes,
Software
ma'am. Normally asking you, is there any like do it right interpretation also?
softwares are only giving us the outputs. Softwares are not meant for the interpretation part.
Okay, ma'am.
Okay. Any other query? Okay. So now we are moving for the paired sample status, that is dependent sample status. So I need to share my slides. I hope slides are visible. May I start?
Yes, ma'am.
Yeah. So we are talking about paired sample status, that is the dependent sample status. So you can see the paired sample status is useful when we want to determine whether the mean difference between two variables measured on the same subjects at two different moments is significantly or statistically significant or not. So to make you understand this particular line, a very simple way to understand this thing is that whenever we are talking about paired sample status, that means two samples should be paired. And when the pairing is possible, when we are taking the same subject in both the samples, right? And in that case, the time will be the different for taking the same subject in the two samples. So say for example, if suppose I talk about this particular FDP, suppose initially I have conducted one of your quiz for understanding that what is the knowledge level of my participants for this SPSS or for statistics, right? And after 7 days, when I have taught this, and suppose at the end of the day, suppose again I'm collecting your responses for the same thing or same number of questions I circulated again. So that way you can see sample will remain same, means you people will be the part of both the conduct, right? So suppose 50 people are coming in the first conduct, same 50 people should come in the second conduct also, right? So that way, this is the pairing of the samples. So that way, you can call it the dependent sample status. Your sample is dependent. You are collecting the data from same person twice after a particular certain period of time, right? So this way, this is the paired sample status. And one more thing, variable will be same. The two variables meaning is 2 times you are calculating the same variable. Suppose I am measuring your performance in the first conduct, and the second conduct also I'm measuring your performance. So I am comparing your performance. Is it clear?
Yes, ma'am.
Yes. Now, assumptions. So this particular paired sample status assumption says the dependent variable is continuous and it is measured twice on the same sample of the subjects, right? So when we talk about the paired sample t-test, we will be having the dependent variable which will be numeric or continuous in nature, and we need to collect data 2 times for the same subject, right? Then the differences between the scores of variable are normally distributed. Means whatever scores you will collect 2 times, you need to calculate the difference, and that difference should be normally distributed. Third says the differences between the scores of variables do not present significant outliers, right? That means there should be no significant outliers available in the difference of these scores. So this way, these are the 3 assumptions you need to check for performing the paired samples t-test, right? Hypothesis can be of the null and alternative hypothesis. If I talk about, I can say the mean difference between the variable scores is equal to 0 in the total population, or the mean score difference between the variable scores is different from the 0 in the total population. I think these are little tough to say. I'll tell you when I'll go to the R data, and then we'll see how to formulate the hypothesis in a simple manner. Talking about what you need to generally report, whether it is a case of independent sample t-test or t-test, one sample, or either it is a paired sample t-test. Generally, we need to report the test value, which is the calculated value, then degrees of freedom, p-value, mean difference, and confidence interval of differences. So these are the things we need to generally report in our results or in our researches, right? Now, we are moving to the SPSS to perform paired sample t-test. So for that, I think I have shared my screen again. I hope it is visible.
Yes, ma'am.
Yeah. So if it is visible, now what you need to do, you can see we are having the grade 1, grade 2, before and after. So I am taking the first 2 columns, grade 1 and grade 2. Suppose I have conducted a test of the student, for example, for the subject maths. I think, yeah, name of the sheet is also maths, right? Suppose I have conducted their score, or I have conducted their test before teaching them, and then I conducted their test after teaching them. For the same number of people, I conducted a test twice with the same number of questions and same number, no, same questions, right? So that way you need to see, you need to firstly formulate the hypothesis. So hypothesis will be there is no significant difference in the grades of students before teaching and after teaching, right? Or you can say that the teaching is ineffective. This will be your null hypothesis. It is clear? Do I need to write it?
Ma'am, is it like experimental study or action research?
Generally, it is we are doing for the experimental studies. Generally, in medical field, we are using it more.
Ma'am, in medical, what is the level of significance?
Sir, I cannot comment on that. Generally, medical is very sensitive, so we need to take level of significance a very smaller figure.
Okay, okay. Thank you, ma'am.
So that you can ask from any expert, because generally, whenever we are talking about the medical field, so there is generally the chances of death or survival, right? So we have
Mhm.
to be very careful. So
Yes.
generally, the level of significance or the type 1 error should be smaller in that case. So maybe it's 1% or maybe more, maybe smaller than that.
Thank you, ma'am. Thank you.
Yeah. This will be the one way of writing your null hypothesis. Other way can be the right? When difference is not coming means teaching is ineffective, right? Clear?
Ma'am, do we check variances also here?
No, in that case, there is no assumption like that.
Okay, ma'am.
So now I think I am again on the data. Now, firstly, you need to see, as I think I said, you need to check whether the variable is dependent variable should be continuous in nature. So we are having the grades. So we can say these grades are in terms of numbers. Hello. Anything you want to ask me, or may I proceed?
Ma'am, can we check once? Can we see that variable view once, please?
I think same sheet I have forwarded to every one of you. You will be also having the same like this.
Okay. Okay, ma'am. Okay. Thank you, ma'am. Thank you.
So first assumption is your dependent variable should be numeric or continuous. So I think it is numeric and continuous, right? Now we need to check the next assumption. For checking the next assumption, I think you can recall it. We need to find the difference of grades, right? So to find the difference of the grade here in this SPSS, you need to go to the transform menu and then you need to select the compute variable. It is fine. You have located it. Everyone found it?
Yes, ma'am.
Okay, if you found, you need to click on this. Now, you can see in this dialog box, your cursor is blinking here in the target variable, right? So firstly, you need to give the name of your variable. So suppose I'm giving difference, right? Now coming to the numeric expression box, you need to shift your first variable using this arrow key in the numeric expression box. We need to find the difference. So I'm using this minus sign from the calculator and then selecting the grade 2 and shifting it into the grade 2 into the numeric expression box after the grade 1, after the minus sign. It is fine. It is okay.
Yes, ma'am.
Then you can click on OK button. In a second, you can see we are having the difference column available with us in the data view. I hope everyone has got this.
Got this, ma'am.
Yeah. Now for this difference, we need to check the remaining two assumptions of outliers and the normal distribution. So for that, again, you need to proceed with the same procedure, that is analyze, descriptive statistics, and the explore. You can shift the difference into the dependent list. You can click on plots. You can deselect HTML leaf. You can click on histogram. You can select the normality plots with tests. It is done.
Ma'am, wait. Just go back one screen. I want to take a screenshot. Done, ma'am.
Done. Click on plots. Deselect this histogram, normality plot with tests. This is what you need to select. Then you can click on continue. So may I?
Yes, ma'am.
You can click on continue button then. And then you can click on OK. In the output, I think we got it. You can see it is showing me we are having total 359 differences or number of observations available for differences, no missing value. Total is this. Now see the mean. I think rather than discussing all this, we are coming directly on the skewness and kurtosis. Skewness and kurtosis, you can see these are very small figures, very near to 0, right? So might be possible I can conclude this thing that the variable or the difference is normally distributed. Looking at the Shapiro-Wilks test, significant value which is greater than 0.05. So what conclusion I will draw here? Anyone? What conclusion I will draw here?
Data is normally distributed, ma'am.
Very good. Who said this? Mona ma'am?
Ji, ma'am.
Yes, very correct. Mona ma'am said correctly that here the p-value is greater than 0.05. That means you need to hold your null hypothesis. And null hypothesis says your variable, that is difference, is normally distributed. Coming to the histogram, if you want, you can put your bell-shaped curve on this. And you can see it is a good type of histogram we are getting, right? Now, QQ plot is, you can see some deviation is here, and skewness and kurtosis are also saying the similar type of thing. So, friends, we can say this thing as exactly normal distributed data finding is very difficult. So, somewhere we can say our data is approximately normally distributed. QQ plot, after coming to the box plot, you can see we are having 3 circles coming, but there is no asterisk sign is coming. So that means there is no significant outliers available, but insignificant outliers are available. As you can see, they are less in number. So if you want to withdraw, or if you want to drop them from your analysis, you can delete, right? But I think this is, I am explaining you for the sake of demo only. So I'm not deleting them. I'm going ahead with this particular 3 insignificant outliers. So this way we have checked the assumptions of the paired sample status. It is fine. May I proceed with the paired sample status now?
Yes, ma'am.
Yeah. You need to go to the analyze, click on compare means, select the paired sample status. Captured map. May I click on this?
Yes, ma'am.
Yeah. So a small box is coming. Here you can shift grade 1 in the variable 1, grade 2 in the variable 2, like this. If you are having more, if you want to perform 2 or 3 hypotheses, or more than one combination of the variables in the same dialog box, so that way you can enter them, right? Then I think do not need to do anything. Using the options, you can check confidence interval percentage is 95%. Hello. So you can check this thing, confidence interval percentage is 95%, right? So you can click on continue. It shows that your level of significance is 5%, right? Changes if you want, you can make. Then you can click on OK to get the output. So may I click on OK?
Yes, ma'am.
Once you're clicking on OK, I think you can see output is generated. The first section says that the mean for the grade 1 is 6.01, grade 2, 7.19. Total number of observations you can find here. Standard deviation and the standard error of mean is available. Talking about paired samples correlation. Whenever you will perform paired sample status, that is the dependent sample status, you will always get the value of correlation. If you want to check what is the correlation value, which is very small figure, 0.007, right? And the significant value is 0.894, which is greater than 0.05. So you can say there is no significant relationship existing between the 2 variables. But usually it is suggestive. This should be accepted. This should be rejected. Means the p-value should be less than your level of significance. Generally, it is the notion, because we are conducting a test on the same pupil, right? So that's why there should be some correlation existing. Coming to the last table, which says for the grade 1 minus grade 2, you can see this is the mean difference coming. Standard deviation is this. Then standard error of mean and 95% confidence interval of the difference is coming. Lastly, you can find we are having the t-value, its degrees of freedom, and the significant value. So this value is less than 0.05. So any one of you will tell me what will be the conclusion here?
Ma'am, teaching is effective.
Teaching is effective. Very correct. So we can say there is a significant difference in the mean grades before teaching and after teaching. And how you can ascertain this thing, that whether the difference is coming and it is positive difference, you can look at this mean value. Presently, before conduct the mean value was this. After conducting or after teaching, when we are conducting the test, the mean is this. So it has improved, right? So that means teaching is effective. Clear?
Yes, ma'am.
I hope it is clear, right?
Yes, ma'am.
Yeah. So I think this is what I performed. Now you can see we are having one more. What I can say. Pair available with before and after. So these are the weights before taking the diet plan and after taking the diet plan, right? I'm expecting you people to perform the paired sample t-test on this particular remaining 2 columns. So I'm stop sharing my screen. I expect any one of you can share your screen, would be a great thing. And that way I can see whatever I taught, whether you got it or not. Anyone can share the screen? It is possible for you to share. Engineering sir is there or not today? I think sir is busy today. Anyone can share the screen? No one? Everyone is only listening today, is it? Yes? I'm not understanding with the thumbs.
Ma'am, I'm performing the test, but I'm not able to share the screen because I'm joining the meeting through mobile only.
No issues. Monama, you perform, and if it is possible for you, you can take a pic. And if it is possible for you to load it on the chat, you please load it.
Sure, ma'am.
Yeah. So apart from Mona ma'am, how many of you are performing? I think Chitra ma'am said she was performing. Apart from Chitra ma'am, Mona ma'am, who else is performing? Yes. Why the people are very silent in the
मैम हमने difference column कैसे create किया था?
Using the transform menu. Compute variable. I think those who are not performing, they need to write the steps. That way, I think it would be easier for them to use the test in the future if they want.
Ma'am, if you can share PPT also with us.
In PPT, I think the steps were not written there, sir. Steps you need to write down.
Okay, ma'am. Okay. In the YouTube, this is also available, na, ma'am.
Sorry?
In the YouTube, it is available. Na? We can.
YouTube means you're talking about this video, this recording?
Yes, ma'am.
Yeah, I think you can go to the website of the RFI, sir. Where you can find, and I think on YouTube also it is listed. So in the group, I think we are having the links of YouTube videos.
Okay, ma'am. Thank you, ma'am.
Maybe Yogaraj sir can share with us again one more time. But probably it is available in the group. Yes, Mona ma'am, any progress?
I could get the difference, ma'am. Now checking the normality.
Okay.
Analyze. Descriptive statistics. Explore. मैम इसमें वही बिफोर एंड आफ्टर दोनों को मैं डिपेंडेंट में शिफ्ट कर दूं?
No, you need to shift only difference.
Okay, ma'am. That's why I got confused. And ma'am, factor list, there is no factor list and there is
nothing you need to
nothing. Okay. I got the output, ma'am. I'm sharing the.
I think if it is possible to share a pic in the Google Meet? I don't know.
Yes, ma'am.
It is
Yes,
possible.
ma'am, should I share in the WhatsApp group?
Okay. And then you can please tell me the conclusion also. So what is the output you are getting, ma'am? Mona ma'am, are you there in the meeting? Hello, Mona ma'am. Am I audible, friends?
Yes, ma'am. I was actually in gallery, so like it took time in switching to video meet. Ma'am, my output is the skewness is minus 0.278
Okay.
and kurtosis is 0.206, means both are in range, so we can assume it is normally distributed data. And
Good.
a significant and p value is 0.879, which is again greater than 0.05. And the histogram seems bit balanced, not as such balanced. And
Then
QQ
box
plot
plot.
is also showing good distribution. QQ plot is showing good distribution, and there are no outliers. I have shared the pics in group. I think like
Fine, ma'am. Good. Now, will you please talk about that next thing?
ma'am, now
How to
analyze,
yeah.
compare means and proportions,
Yes.
and then uh, paired sample t-test,
Yes.
uh, pair variable one is before,
Hmm.
just a second,
Variable 2 is after.
just a second.
Then
Wait, ma'am, it is being done. Variable two is after, and anything else I need to define, ma'am?
sorry. No, you need to only
Anything
tell
else?
me no, only you need to tell about the paired sample test results.
Means variable one and variable two I define. Anything, any else correction I need to make in this?
No. You need to click on
I
OK.
got the test results, and what I can find is, should I directly go to, हम कौन सा वाला देखना होता है इसमें?
You need to see the
Paired
last
sample.
table. Last table. Last table.
Ma'am, this is less than 0.001. That
Okay.
means
So
null
we are
hypothesis
going to
is rejected.
and we are concluding that the diet plan is effective.
Diet plan is effective. Yes, ma'am.
Very good. So I think this has given you confidence, right, Mona ma'am?
Yes, ma'am.
So
Yes,
that
yes.
is why from the day one I am emphasizing, please perform along with me. So this will give you the confidence, right?
Yes, ma'am. Finally, मेरा SPSS आज ही download हो पाया.
Okay, okay. Finally it happened. What was the problem?
Yes, ma'am. Ma'am, it was like earlier I have also downloaded it. So like I was not changing the email ID and some that sort of problem.
Fine, fine, fine. I think it's great you finally performed by your own and you got confidence, right? So that's great. And I think this is the main purpose of conducting this type of FDP, right? So thank you so much, Mona ma'am. And I think this is all from
Thanks to you, ma'am.
my pleasure, ma'am. So I think this is all from my side for the day. Now the platform is open for the question and answers. If you are having any question regarding t-test, whatever we discussed today, please ask me.
Madam, I am not able to download the software and do it so far. So theory part is okay, but I'm not able to. I think that is the problem with the majority of the people. That's why everybody is silent.
I
So
don't
we could
know,
do.
sir. I think whatever is my experience, many a time it happens. People, I think, only joining to listen. Probably they're not performing. Probably this is what my experience says. Till now, I think I have conducted so many FDPs. Only few people, like 8 to 10 people, are generally interacting. Remaining are not interacting. So I cannot come to the conclusion. I think why do the people are not speaking or something. But might be possible your reason is the same. Your reason is that you are unable to download it, right?
Yeah, exactly. I have mailed to you also the screenshots, whatever
But
screenshots.
I think that from looking at the screenshot, it was not clear to me where you were stucking and what the problem you are facing. I think yesterday also we had word. I said to you to change your mail ID. Have you done
Yeah,
that? Have you your device?
today. Yeah, today I tried with a different phone number and a different email ID also, but still
So
didn't.
previously you have downloaded on your same system on the same
No,
laptop.
first
Laptop
time,
is different.
first time I am using SPSS. I never used earlier.
So what the problem or trouble it is throwing you?
Yeah, I think I have shared in the group also the PDF file.
But sir, I think looking at image, it is not clear to me. I think I have shared one video regarding how to download the SPSS. Have you seen that?
No, I have not seen that.
I'll share it again in the group. You please
Yeah,
check it.
please. Yeah,
Probably
please.
it will help you out, right?
Yeah, definitely.
Yes. Any
Actually,
other
2 days.
sorry?
After 2 days only, I could join the group. I think. First day I could not join the WhatsApp group.
Okay. Are you there in the group right now?
Yeah, I am there.
Yeah, fine. Okay. Any other queries?
Ma'am, I am having a PDF file of Reserve Bank of India containing 2 years, previous year and current year, and it has many variables. Means, as we were talking about one dependent variable only, here I could find many dependent variables and only one reading for one variable. Like deposits, last year itna tha, is saal itna hai, borrowings last year itna tha. Then how can I perform that paired sample t-test? Do I need to perform every time separately for each of these variables?
I think I have shown you, ma'am, there in that particular window, there is one more row is there. So that way, if you want to enter so many different things, you need to only shift them.
I
and
can
remember
add
the
there. I can add there at one go.
Yes, yes.
Okay, ma'am. Okay, thank you so much, ma'am.
Thank you, ma'am. So any other queries?
Madam, can you please see that one? My screenshots.
Sir, I have gone through. That is why I'm saying it is not clear to me where you are stucking.
That is what all the screens, whatever screens are there, they are coming. I
I
am
have
stuck
seen
up.
everything, sir. You have shared me on mail. I have seen the mail.
Yeah, the last one. I am stuck up at the last one. That's all.
But I'm not getting the problem. It is not showing the problem.
No, that is what, madam. It is not installing at all. Displaying the.
It is problem, sir. Na? So how I can understand what is the problem? Why it is not allowing you to download?
I have not. It could not download at all. It is showing this my products displaying filtered list. See, first one.
I
The
understand your problem, sir. That is what I'm saying. I understand the problem, but the screenshot is not showing any problem to me. That something should be written there. That this is the reason. That is why the person is not able to download it. But it is not shown by that particular screenshot. So that's why I cannot comment. So I'll share the video. Please check it. Probably it will help you out.
Okay, sure.
Okay. Any other
It
query?
is, madam, it is in the last one. It is showing. It looks like you don't have any products. Displaying filtered a list of products. There is a blank there. Question mark is there.
I think that I have seen your screenshot. That is what I'm saying. I think you can see just a minute.
Actually, it should contain the product. I think there in that box, the product should appear. Then I can download that. I will go through the video. No, it's okay.
Have you seen the video, right?
No, I will see the video.
Okay.
You told you'll be sharing to now.
You can see, I think this is the mail you have sent to me, right?
Yeah, please.
I have seen your these images. But I think I'm not getting the problem exactly where you are stucking.
No, nothing is
The
installed.
problem
That's all. That
looks
is
like
hanging. That's all.
right?
That whatever screen, 10th screen is there, that is
Yeah,
just
yeah. It
hanging.
looks like you do not have any product. So that is what I'm not
I don't
getting.
know.
Why you are getting this screen? This is the problem I'm
That's
not
all.
understanding.
That will be there for forever. That's all. No progress after that. I don't know.
That is what I'm saying. I'm not understanding why this particular thing you are getting. It looks like you don't have any. Have you clicked on purchase or something?
No, I have not clicked anything.
So I think that you refer a video, probably it will help you out. I think
Yeah,
apart from that, I
definitely.
cannot comment anything.
Sure, I will try.
Yes.
Yeah.
So I think this is all from my side. If you're not having any queries, we can ask for a photograph if you can switch on your cameras, and then we can wind up our meeting for the day. And Yoga sir, I think tomorrow we are not having a class, right?
Yes, ma'am. And
Yes.
tomorrow is Sunday.
So we are meeting on Monday now. Yes. Oh, I can see Mona ma'am, I can see Rao sir, Shagun ma'am. I think for the first time, Shagun ma'am, I'm looking at you, right? Rama ma'am. I think yesterday, Rama ma'am, are you traveling somewhere? Rama ma'am, are you traveling somewhere yesterday? I think when I was teaching, I have observed this thing. Probably you were traveling somewhere and you're listening.
Yeah. I was traveling from the college to house. During that time, I listened to your class. That's all.
Yes,
Only
yes.
listening,
Yes,
not practicing.
I understood that thing that you are listening to, but I like this thing. Even you are having that spirit, you are listening to the
Yeah,
things which I was discussing. That's great.
I'm helpless because I can't this one execute whatever you are saying because I'm in traveling. So later on, I have to practice your content, whatever you are given.
No issues, ma'am. I think this spirit is enough. But I think if you want to learn, I think you should practice. I think Mona ma'am today
Yeah.
performed, so probably she got that experience and the confidence today, right?
Okay. Thank you, ma'am.
Thank you so much, Rama ma'am,
Thank you.
Mona ma'am, Shagun
Thank
ma'am,
you.
Krishna sir, Indranil sir, everyone, those who are there in a meeting. Thank you so much. We will meeting on Monday, and I'll discuss the correlation and regression on that day, right? So that's all from my side. Have a nice weekend to everyone. Good night. Take care.
Thank you, ma'am. Good night.
Thank you, ma'am.
Thank you, ma'am.
Savita ma'am. I need to capture Savita ma'am also. Just a minute, Savita.
Good evening, ma'am.
Good evening, ma'am. I captured. Thank you.
Thank you, ma'am.
Thank you so much, ma'am.
Thank you, everyone. Yoga sir, we can wind up the meeting for the day. Thank you. Yeah, thank you.